Hello there, Algebra Masters. This is a special video 4.11, on something called the quadratic formula. So some definitions you need before we get started is what the quadratic formula is. It is a method for finding the roots of complex quadratics where you cannot use x factor or factor out a GCF. So the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is not something you have to memorize, but it's something that you need to write down so you can refer to it. And then just remember that standard form, we can only use a quadratic formula when your function is in standard form, and that is ax squared plus bx plus c. So let's see how this works. Now we have this example. Solve x squared plus 3x minus 4 equals 0. And when you're looking at it, you'll probably say, oh, I can just do x factor and find out what multiplies to negative 4 and adds to positive 3, which is positive 4 and negative 1. So I write my roots, x plus 4 times x minus 1 equals 0. And I set these both equal to 0. And I find out that my roots are negative 4 and positive 1. That's a pretty simple way to do it, but let's see how the quadratic formula can do the same thing for us. Using the quadratic formula, so as I said before, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now my algebra teacher made me memorize that, but I won't do that to you. So all we have to do is plug in our a, b, and c values. So let's start with negative b. The b value is 3. I'll put that in blue. Plus or minus the square root. We have b again, which is 3 squared. Minus 4 is always there in the formula. A we'll put in red. A is the ninja 1, so we have 1, that's a parentheses, times c, and we'll make c green. C is negative 4, so times negative 4. And that's all over 2 times our a value of 1. And now we just evaluate this. So again, we have negative 3 plus or minus the square root of 3 squared is 9 minus, so it's negative 4 times 1 times negative 4, so that's a positive 16. So we have 9 plus 16 all over 2 times 1 is 2. We have negative 3 plus or minus the square root of 25 all over 2. That's negative 3 plus or minus 5 all over 2. So what we have to do now is break this up, because of this plus or minus sign here, into negative 3 plus 5 divided by 2 and negative 3 minus 5 divided by 2. So negative 3 plus 5 divided by 2 equals 2 all over 2, which equals 1. And then negative 3 minus 5 is negative 8 divided by 2, which is negative 4. And if you look back at the notes you took for the first part of this example, you see that the roots that you found were 1 and negative 4. So that's what the quadratic formula does. It finds our roots for us without having to factor. Now you may be thinking that was really complicated, I'm never going to use that, I'm just going to factor. But sometimes you're going to get examples like this where it's just not so simple to factor and you need to use the quadratic formula. So that's what I'm showing you today. So again, the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have it negative b is 5 plus or minus the square root of 5 squared minus 4. A is 2 in this example. C is negative 3 in this example. All over 2 times A, which is 2. So we have negative 5 plus or minus the square root of 25. Let's see, negative 4 times 2 is negative 8 times negative 3 is positive 24. So plus 24 all over 2 times 2 is 4. We'll go up here, we have negative 5 plus or minus the square root of 49. 25 plus 24 is 49. And I'm just following order of operations to simplify all this. So I do everything under my radical first. Divided by 4. I have negative 5 plus or minus the square root of 49 is 7 divided by 4. So again, I have to branch this out into negative 5 plus 7 divided by 4 and negative 5 minus 7 divided by 4. So negative 5 plus 7 is 2 over 4. So we have 1/2 as one of our roots. Negative 5 minus 7 is negative 12 all over 4. So we have negative 3 as one of our roots. So as I said before, we can always use the quadratic formula to find our roots, even when we can't factor. So again, you're not going to have to memorize this or anything. It's just good to know how to use it. It's all about substitution and knowing standard form. There's something else with the quadratic formula called the discriminant, and this discriminant is the expression that's under the radical sign. So in our formula, under the radical sign, we have b squared minus 4ac. That is the discriminant. And what that can tell us when we evaluate b squared minus 4ac is how many solutions there are. So please get this whole slide down. If the discriminant is a negative number, so when you evaluate this, it becomes negative, there are no solutions. That means that the parabola will not cross the x-axis. If the discriminant is 0, that means there's one solution. There'll just be one point at the vertex where that parabola touches the x-axis. And if the discriminant, when you evaluate this, comes out to a positive number, it means that there's two solutions and it'll cross in two places like you've normally seen. There are two roots. So what does this mean? Well, this parabola right here would have a discriminant of 0. Because there's just one solution right here. So when you evaluate b squared minus 4ac, that will equal 0 for our first graph there. In our second graph, because it does not cross the x-axis, that means that our discriminant was a negative number. And then for our third example, there are two places where the parabola crosses the x-axis. That means that the discriminant evaluated to a positive number. So what you can expect when you take your regions is you might see a question that says, how many solutions does the function, and I'll give you a function like we have here, how many solutions does it have? So how many solutions are there to p squared plus 10p plus 25? And all that means is how many times does the parabola that is graphed by this function cross the x-axis. So all we have to do is plug our values into our discriminant of b squared minus 4ac. So I have b squared minus 4 times a times c. And I'm going to plug in my b value, my a value, and my c value. So my b value is 10. So I have 10 squared minus 4. It's always in the formula. There's a ninja 1 in front of p, so a is 1, and then 25 is my c value. So I have 10 squared, which is 100, minus 4 times 1 times 25. Well, that is 100 as well. So 100 minus 100 equals 0. Now, as I know from my notes before, it's going to be just like this graph, where there is one solution. So all I have to answer for that is there is one solution. Now your hot question. I want you to try to use the quadratic formula that you just learned to solve 2x squared plus 7x plus 4. Remember, you are just substituting your values and finding your two solutions or roots. So I want you to write in your answer when you evaluate x equals whatever the answer is, and then x equals whatever the other root is. Good luck.